Welcome, BG. What I'm really interested in a way is you went to Yale, it's computer science, is that when you got out, what were your expectations? What were you hoping to do?
I had no idea. I was going to become a professor at University of Illinois Urbana. This was post-Reagan, so there were huge grants coming to these things called the supercomputing centers that the kids here will not know about. So basically Stanford, Caltech, Rice, Yale, Urbana, and Michigan. And a lot of the all the stuff you guys are using now at the GPU level, it's funny to say this, a lot of that stuff came from the parallel sparse matrix stuff we did back in the day, and parallel blast stuff, and is now coming back 30 years later. But anyway, I worked a lot on parallel algorithms for scientific problems, and then accidentally got my PhD around graph partitioning. And I was going to go teach at Urbana, and my advisor said, "You're not suited for academia. You're much too impatient. So go west, and don't work on hardware, work on software. That's it." And I had no clue how to apply. I had a paper at supercomputing, and there was some company called Informix there. I had no idea what that was. I'd never taken a database class. So I would say that was the lucky break. I ended up going to at that time, the hottest database company. You remember, it was killing Oracle and Sybase and Ingress at that time, right? So for those of you who don't know, Informix had two beautiful products. One was an OLTP product, one was a data warehouse product. Amazing, and then things went wrong on the CEO side, so the company did not do well. But yeah, I would say I was lucky to start my career in data kernels. I spent many years at Oracle in the RDBMS team. And if you think of the team we had, imagine Snowflake came out of our team, right? Benoit Thierry and I wrote a lot of code together. Ashish started Qbol, Vipul started Rubrik, Dheeraj started Nutanix. So those two floors have probably the most number of unicorns coming out and infrastructure. So I would say the schooling at Oracle was really important. I went to Yahoo late. I was really lucky to run this really hot ad exchange called Byte Media. And we got to do some fairly deep distributed systems, indexing, information retrieval work there. We got to publish papers. And then LinkedIn, 5 of us went to LinkedIn end of 2009, when LinkedIn was growing really quickly and didn't have a very clearly defined data infrastructure strategy. But we can dive into that more. But I would say those two, Oracle's schooling in RDBMS is what I'm most grateful for. It's the most beautifully designed product, which just stood the test of time. And the engineering culture I saw at Oracle, the meritocracy, was quality of code. Everything was so amazing in the kernel team, right? I'm extremely indebted to that phase of my life.
So I have a question for all you kids out there who may be new to the data space. How much do you think your kernel work has influenced how you process what's going on more the user side, the data engineering and data analyst side?
Yeah, when you work, I would say if you start your career in old time like networking stack, if you worked at like AT&T Bell Labs, or you worked at IBM DB2 or Oracle, these are very complex systems, some of the most beautiful code ever written. But the main thing you learn by being in a group like this is separation of concerns. You start thinking about architectural stuff a lot more. You start thinking about APIs a lot more. We didn't call them APIs at that time. We would call them functions and parameters, right? That was one, I would say, separation of concerns and systems thinking actually is really important for both data infrastructure building as well as data infrastructure businesses, right? I think the thing you and I discussed about product geometry, persona, user geometry, budget geometry, this thing of geometry or what you call lattice, I would say a lot of those mental models came because we got to work on such complex, multi-tiered, beautifully architected software products. So.
Right. Just in terms of those two kind of framing, a way to think about data, just want to talk about that for a minute. We're all familiar with the word stack. And I think stack really became popular when the LAMP stack was something, because it really was a stack. Things were piled on top of each other.
Which came out of Yahoo. I just want to call that out for the young people here.
That's right. And it's also funny how radical having an open source stack was at the time.
Yeah.
It's hard to imagine it now with open source so embedded in the way we think, but back then it was like Martians had come and taken over software. But I think in the data space what's changed is that, from my perspective, this lattice metaphor works, where you've got all these nodes, and then the edges are where processes take place. And then BG has described these geometries, and I'll let you explain it in a second. And I think framing is really useful. But the thing I want to say about that is it's a layer of abstraction using these metaphors. And I think that that's been one of the things, as we talked beforehand, that we'll probably reference more than a few times, is that the increasing levels of abstraction means that more and more people can use the data. So why don't you explain your geometries?
Oh boy. Do you want me to give a little bit of the LinkedIn background, or do you?
Why don't we do the geometries first and then go into?
Yeah. So jumping right ahead, the thing we think about as builder. I mean, I also start companies as part of ADVC. Just started a stealth analytics company which uses GenAI. Something that we force ourselves at ADVC to think about is first and foremost product geometry and persona geometry. So product geometry is, suppose you want to build a new product in the entire data lake, data warehouse, analytics, ETL space. It's good to go to a whiteboard and kind of draw out building blocks of what exists today. Is there an ingest piece? Is there an ETL or ELT piece? Is there a substrata of a data lake piece, or a blob store piece? Is there a BI tier? Is there a SQL democracy tier like dbt? Is there a warehouse sitting on the side? Is there such a thing as reverse ETL? When you draw all that out, you are forced to think about how do they fit together? How do they use each other? How do they integrate with each other? And then you'll start finding out that some pieces that you're trying to build does not fit into it. You have to start thinking about why doesn't it fit in? Is it an API problem, usage problem? Is it that you are putting too little functionality in? Let me give you an example. So we started this metadata project at LinkedIn. It was called something else in 2012. And then Shashanka took it over and turned it into this massive open source project called Data Hub. And then from ADVC, we funded this company called Acro. So initially, you think of Data Hub as a data catalog. Well, everybody builds data catalogs. Not very interesting. Then you start thinking, what's in that data catalog? It's actually a metadata plane, which will have information about tables. It will also have information about pipelines. Someday it will have information about AI models and their lineage. Then you start thinking, is that product itself a geometry that will work? The answer is no. Nobody will pay for that metadata plane only. They will start paying for workflows on top. Then, you need a search and discovery vertical workflow. You need a data quality and observability workflow. You need a governance workflow. Maybe you need data lifecycle management. So if you start thinking in that way, then what does your MVP look like? How does it fit into it? Which personas use it? We have found that at ADVC and in our team, which does fairly heavy lifting in data infra, we found that a very useful mental model. And what we do is, because a lot of my old friends now run really large data stuff at LinkedIn, Pinterest, Airbnb, all of us old timers have friends everywhere. I often go and kind of run this past them, saying, what does the product geometry look like for you internally, even if you're not open sourcing it? So it's been a fairly useful mental model. So.
Okay, great. Now, you said that when we talked, you had said there were three. There's the product
geometry, budget. So first is persona geometry, second is product geometry, third is budget geometry. I would say the first two things that you have to think about for go-to-market as a builder is product geometry and persona geometry. If you don't get that right, it's very hard. Of course, budget has to come after that, but yeah.
Yeah, what's interesting too about the persona geometry from my perspective, when I first started building data teams in the mid-90s and beyond that, we didn't separate out analytics from data engineering. Everyone did everything. But over time, particularly as data got larger, that you needed a little more specialization in it. So having established this way of thinking about things, let's talk about your experience at LinkedIn. What a cauldron of projects.
We were just trying to survive day to day. So we got there, most of us, I was very lucky. In my entire career, I'm always lucky to work with people smarter than me. And I always worked on data. Those are the two formulas I've seen. Hard formulas, but if that's true, then you'll probably learn a lot. When we got there, we were at 50 million unique users in the graph, which at that time we thought was huge. When I left, fall of 2014, it was 575 million. So, it went through. that level. Facebook saw even more growth, but LinkedIn as a source of truth graph is hard. So the first thing we had to work on was the online side, which this conference is a bit more analytics and data lake focused. The source of truth databases, I don't see a lot, but anyway, so I'll keep that part short. So much of LinkedIn at that time was running on Oracle. And Jean-Luc, who was the founding CTO of LinkedIn, you guys who are interested in history, wrote an amazing paper at QCon 2007 or 8 about change data capture by reverse engineering Oracle redo and undo logs. Amazing. That guy was a genius. So we had this thing that was called data bus, and we had a bunch of Oracle instances, and everything was falling over. And I was lucky to hire a lot of smart people, Shashanka, Swaroop, Kishore. Sui came, Jay Krebs was already there before me. We had no idea what to do. So we kind of started looking at MongoDB very deeply. We brought in MongoDB, and it keeled over within 2 days, which is okay. Mongo is a beautifully designed product, way ahead of its time with the whole document style DSL, which is really important. Kind of did something that old-timers said Yahoo should have done with the LAMP stack, but Mongo did it first. So we looked at it, and then we were lucky to go to either VLDB or Sigmod. Because you mentioned Jeffrey Dean, I wanted to tell you, I didn't tell you this. We were at we were in Indianapolis at a Sigmod or VLDB. And this is like first 3 months at LinkedIn. I have no clue. I've hired these really smart people. We have no clue what to do. We know that we have to build something with the document style programming and data model API. So I talked to Jeff Dean, basically like going to Moses and Muhammad, going to the mountain saying, what should we do? He gave a really good piece of advice. He said, do not build the backend from scratch. Use something off the shelf, which is open source. And that was like amazing advice. So we ended up building what turned out to be the biggest piece of data infrastructure at LinkedIn that nobody has ever heard about. It's called Espresso. It's a source of truth database, horizontally scalable. We built it initially with a MySQL InnoDB backend for the transaction part, and a MongoDB-like programming API on top. And you guys will be surprised to hear 80 to 90% of all of LinkedIn still runs on, I would say, thousands of instances of Espresso, supporting 5+ million QPS. I would say that was the heaviest lift. I would say the Espresso journey was the hardest journey for LinkedIn data infrastructure on the online side. And then Jay, Neha, Joan, and team did an amazing job with Kafka. Data Bus, which is the change data capture thing, we just wrote a check into a Y Combinator company called PeerDB. Change data capture is still a very hard problem. Bringing change data logs to where it needs to be used is very hard. So that's why we built Data Bus. I remember Shashanka wrote a beautiful paper back in the day, but we merged it with Kafka finally. Right? So, and then we of course had a cache, and then we built a very good graph engine which kept on getting updated. I didn't build it, another team did, but I would say those were the 4 key pieces of the online side. So that was the online journey. We just want to keep it brief, but I'll hand the mic over to you. What other you want to?
Sure. One of the things I want to talk about is this fits in with this pattern where I think you'll hear a few times. Why were they building this? No one was providing these things. And open source has its issues, and we can talk a little about that. It is good at functionality. It's kind of pared down usually because someone is doing a point project. I think, and I don't know if Julian Ludem is here, but I think he's an exemplary open source project person, and he did Apache, Arrow, and Parquet, and I think he really did a great job of reaching out horizontally. But open source leads to a lot of fragmentation, because now you've got a lot of piece parts because all these people are solving these problems. But they do sometimes coordinate, and you used a great term, and it was the spirit of
service. Is that what we talked about?
Spirit of service. That why would you build this when you're at LinkedIn, when you're not going to be a company selling these products? Well, it's because you can't buy it anywhere. Why open source it? So instead of just your team, you can have tens, hundreds, thousands of committers perhaps, helping you refine your product and taking it to the next level. It's a great virtuous circle in a lot of ways. And I think that's why open source has become so important to the world, to it. But you seem to kind of live this spirit of service
Yeah.
Or maybe you can explain how that affects.
Open source, I want to call something, Jonathan Goldman, you mentioned him. That guy was amazing. He's the guy who came up with this amazing thing called people you may know. You know how you densify the graph, that Facebook. We should have patented and got an IP on it. He did it before we got to LinkedIn, so amazing guy. Spirit of service, yeah, I think it's funny. As a VC, finally you find out that you don't have control of anything. Nobody will listen to you. So you're ultimately here to serve the entrepreneurs and maybe nudge them a little bit, right? If you build data infrastructure or AI infrastructure, you build horizontal disciplines in an enterprise, ultimately nobody would want to listen to you because they're busy shipping their product. And I think the personality of evangelization that you have to take on is a very, very light touch one, steeped in a spirit of service because you're trying to make the product side successful. In very infrastructure heavy culture companies like Google, maybe you don't need to, you just can go. But I would say something we did very well at LinkedIn was actually evangelize stuff, get people to adopt in the right way slowly and not railroad them. And we talked about the spirit of service and influence and evangelize rather than force as a very, very key part. And when we were building infrastructure, I remember when we built Espresso, the amount of time we spent with the feeds team, the profile team, the mail team, which were major teams at LinkedIn who came before us, seriously good engineers. We had to spend a lot of time with a lot of humility listening to them. And that was very well done. And what ended up happening with the programmability, the DSL side of the online side is, because we listened to them with a lot of humility, the data model design of Espresso was amazing. The extensible JSON-based data model design. So humility might even lead to good design. That could be one.
Right. I actually think open source actually helps with the whole humility equation.
Yes. Open source, at that time we came from Yahoo. Yahoo was just a spectacular place. Yahoo hackathons were legendary. I mean, during my grad school days, I first learned about open source from this crazy guy named Richard Stallman, who would come to Yale to talk about it. Too many young people that here may not know about it, but anybody who's hacked Emacs Lisp, which you and I did, we owe a huge debt of gratitude to Stallman. But then Yahoo was a cauldron of open source, just open, very democratized stuff, sharing, right? During my time, there were probably 50 plus implementations of distributed hash tables inside Yahoo. Can you imagine? That people were using with each other, which is crazy because hash tables, DHTs are very hard to implement. I would say the Hadoop thing was amazing at Yahoo. Sadly, with two companies being formed, all of that stuff. When I went to LinkedIn, LinkedIn was just beginning to adopt Hadoop and became probably the biggest user deployed enterprise use case of Hadoop other than Yahoo. It was massive, and now it's still there. It's slowly getting out of Hadoop. But open source at LinkedIn was part democracy, part we had to compete. We had to go hire engineers who had offers from Google, Facebook, PayPal, eBay, all great companies at the time. And we found that open source was also a hiring mechanism. It was also a cultural mechanism. And now I realize that open source is also a quality mechanism. If you're doing open source, you will get found out. If you don't do a good job, the community doesn't have anything to lose by telling you that you're wrong, right? So I would say all of that, 80% of that we got right at LinkedIn. And continued. I left end of 2014, but I think it's continued. They've done amazing open source stuff. I think the whole iceberg-based thing called Open House they've come out with is beautiful. Bunch of stuff, a lot of good open source stuff. I mean, I think LinkedIn even committed to pretty sophisticated shuffle stuff for Spark. I forgot what the project is called, but I was looking at it. So open source was a cultural aspect, hiring mechanism. Now what's the flip side? Flip side is once you are actually building stuff and shipping to production, how do you maintain the balance of outward facing time versus production time, right? Because open source also has a lot of seduction about it. There's a community, you go and give talks, right? You enjoy the interaction with other people, with other smart engineers. And shipping stuff to production, fixing P0, P1 bugs is boring and hard. So I think from a management and leadership perspective, that balance has to be struck, right? That's number one. Number two is, you mentioned fragmentation, and I'll just make a brief comment. I think data usage, data type, exploded in most large enterprises. Facebook was amazing. I think Facebook just did phenomenal work in all parts of data. LinkedIn, surprisingly, we did, and it's continued. The tradition has continued for the last 10 years. I left 10 years ago. Well, what happens when you do open source and when you have an enterprise where data is a first-class citizen, where profit is tied to data, not just cost? People tend to build a lot of bespoke stuff. And now you go and open source it, right? So what happens outside? So that's a much harder question. Would a company survive there? Can a VC invest in it? So I would say the same thing that a lot of us have done, and people, the community I was part of has done, is we have open sourced a lot of stuff, which is a good thing. But this supermarket has also become very large. So I think for good or for bad, there is a lot of fragmentation. So now you start thinking about it from a user perspective. If you're the head of data engineering or IT at a big bank, how many things are you going to bring in? Are you going to bring in 15 moving parts, or are you going to pay for 4, right? And that's one part. The other part that VCs are having to think about is open source projects give you one huge unfair advantage, which is a bottom-up go-to-market network effects, if it's done well. If you look at Kafka, you look at ClickHouse, look at DBT, you look at Data Hub. Fair enough. So the distribution advantage is there. The question is, how do you make sure that you can rank open source projects as an investor and builder as something that will become economically viable? I think that's a fairly hard problem. I'll just leave it at that.
Yeah, I want to, in a way, take off from that. The tech hubs, Austin, San Francisco, Seattle, New York, Boston, tend to attract a very high level of dedicated engineers who are interested in solving particular problems. But there's a huge world beyond them. And I think sometimes those folks with a very tight engineering focus don't pay enough attention to the users. And they think all users are as sophisticated as they are. And they aren't. They have just a less engagement. They didn't get the academic training or whatever. I'm curious, now as you're an investor and you're thinking about things around open source, how much does thinking about the user and the use cases matter in terms of your ability to make decisions and figure out
Can we talk about the DSL part of user a little
absolutely.
bit? I think Roger and I had an amazing couple of discussions. We only know each other for 2 weeks now. We've been finishing each other's sentence. It's been amazing, yeah. 2 old fogies, yes. But we've been lucky to do what we have had. The timing for our careers has been amazing, no? So I think the one thing Roger and I talked about that's fascinating for all you guys who want to build companies is, what is the lingua franca, right? I mean, from my first half of my career, the lingua francas that ruled were SQL in the bottom half and PL SQL, something procedural on top. And, and then PL SQL let you do more complicated things, manage sessions, open cursors, all of that stuff, which a SQL query declaratively, it let you manage state, right? So that will never go away. If you look at what's happening in the Python, Jupyter Notebook, Pandas area, what it lets you do is really to manage state and be sticky, right? That you do something, publish something, do something, publish something, right? So we started thinking, what about SQL? Because we all thought SQL would die 15 years ago.
Just for what it's worth, I never did.
You never thought.
I got into
So what has happened
Any
is...
old Hadoop people here remember me arguing about the lack of SQL?
Yeah. So funnily, we owe the Hadoop community, especially Joy and Ashish from Facebook, who invented Hive, huge debt of gratitude, because they ultimately said we can make SQL work directly on top of MapReduce and blob stores. That's unthinkable, right? Remember at Yahoo, we went the other way. We went the PL SQL route and built Pig. By the way, Pig and Hive both got the Test of Time award at Sigma, and it's kind of important. I hope the young practitioners here pay attention to it, because a lot of sawtooths happen, right? SQL, I would say for Hive, and then I want to call out DBT. DBT is amazing because it started really codifying SQL as code. That you can check in SQL, you can share SQL, you can almost share views in SQL, right? So SQL actually exploded in the last 10 years, whereas we had expected SQL to die, right? So it's important from a user perspective for anybody building or thinking of users to think about what language will they program in. I would say the second thing that happened is at LinkedIn, when I was there, all the fundamental ETL pipelines, okay, ELT, we're not going to argue about that right now, were built in Java, Java Hadoop. So today, I would say because of Iceberg and because of Arrow and similar projects, you have a polyglot set of stuff running on top, right? You can have Python, you can even, God forbid, you can write it in C or Rust, you shouldn't. Maybe even Java. So there's a polyglot set of stuff. Now, if you look at those languages actually running in production, I don't think the user community is that big. It's a bunch of data engineers, right? So it's important to think about that if you're going to build a company below, what is this community going to do? So that's number two. So one is SQL, one is this. Then you start thinking about the revolution that our old friend DJ, who's coined the term data science along with Jeff, right? I would say the data science community has brought a lot to the table in the experimentation phases, especially, right? Again, borrowing from PL SQL, session-based work, Jupyter Notebook, and Python. Python has become a lingua franca there. So that is not going away. So now you have that community. So if you want to think about that user geometry, what will that do? We did do a company called Ponder, which was the Python pandas, with the project was called Modin, open source community that came out of Rice Lab, which we sold to Snowflake last year. If you guys want to do companies or build stuff for that user community, which is in the experimentation phase, maybe even the serving phase of models, think deeply. Is that community going to be able to pay you a lot of money or not? I'd leave that as an open problem.
Sure. So time flies when you're having fun. We're running out of time. I hope people have a couple questions. Just wanted to say a couple key takeaways that, as we talked about this beforehand, I just want to kind of go over. Hopefully, it'll be something that you get from what's here. One is there's an expression that history doesn't repeat itself, so it rhymes. And I think from our perspective here, being in the space a long time, we're seeing a lot of rhyming. There's things that are going on now where there's precedent before. It doesn't mean it's going to be exactly the same, but you have a context for thinking about it. So it's worth knowing history. Zhamak showed the original Unix paper. If anyone wants to talk to me afterwards about remember the 70s, I've got a great thing about that. Two is just being curious. Luckily, the data space encourages that being curious. Watch what folks are building when the thing's not available, because there's a market need. I mean, it's so important to see that. And you mentioned humility. It is the best way to learn is to figure out you're wrong and focus, change, and learn from that.